am Renu Sharma, Assistant Professor, EC Department. Today I am going to start with the next lecture, and the topic of today's lecture is Random Access Protocol. So, these are the contents of today's lecture, that is we will discuss this random access protocol, that is part of multiple access, then control access protocol. So, basically when more than one user are combined together, which will going to access a common channel on different based on different protocols. So, that will be known as random access or controlled access protocol. So, this is the flow diagram or the division of multiple access protocol into three different sections. Like first one is the random access protocol, which means that the user, any user who is going to access the channel will not wait for any amount of time until and unless they will receive a message, they have the message, they will going to transmit the message without seeing that whether the channel is free or it is busy, it is ideal or busy. So, based on this random access protocol, there are different types of protocols. Like first one is ALOHA. ALOHA is again divided into two types, like first one is pure ALOHA, second one is the slotted ALOHA. We will discuss later in the lecture. Then CSMA, that is carrier sense multiple access. Now, this is again divided into two parts, like first one is the carrier sense multiple access collision division and collision detection, and this one is carrier sense multiple access collision avoidance. So, these two are part of this CSMA. Next is control access protocol. This we will also going to discuss in today's lecture. Like first one is the reservation, then polling and token passing. So, these two topics we will discuss. Now, we will begin with what is random access. So, in random access or contention method, no station is superior to another station and none is assigned the control over another. So, which means that there is no pattern decided, like there are, let us say there are 4 different users S1, S2, S3 and S4. These 4 users are connected together, they want to access the common channel. Now, there is no definite pattern is there, like first user will transmit the data, then second user, then third user and fourth user. So, this is not the pattern, whichever user is having the data, they will going to access the channel. So, that is known as random access protocol. So, no station permits or does not permit another station to send, and each instance a station that has the data to send uses a procedure defined by the protocol to make a decision on whether or not to send. So, this is the same description, that there is no pattern is decided that first user, second user, third user and fourth user. Maybe first user will send the data, then third user will then send the data, then second user, then fourth user. So, any pattern can be followed. So, based on this, there are 3 different types of 3 to 4 different types of patterns are there. Like first one is the ALOHA. Now, what is ALOHA? ALOHA, it does not has any specific full form. Like in pure ALOHA, this is an example which is showing that 4 different stations are going to access a common channel. Now, these are having 2 frames each station, like first station is known as frame 1.1, then second frame is known as frame 1.2, second station is frame 2.1, then 2.2, for third one this is frame 3.1, then 3.2, frame 4.1 and 4.2. So, these are the different frames, like 2 frames each station will have, and they will going to transmit or access the common channel. Now, in case of pure ALOHA, there is no order is followed, it will going to transmit whenever they are having the data. Like in this case, frame 1 will be sent, and you can see over here that frame 1.2, second frame of the first station, first frame and first frame, these 3 are the first frame of station 2, 3 and 4 respectively, and this is the second frame. So, you can see that some part of these are overlapping. So, this means there is collision, this is known as collision duration, and due to this collision there is loss of information. Now, then this second part is also there. So, this is also having the collision duration, and you can see that this is not going to overlap with any of the frame from the respective station. So, there is no collision. So, here at these two places the collision will take place. So, this is the concept of pure ALOHA. Now, this is the flow diagram that how random access protocol in case of pure ALOHA will going to access the common channel. Now, this will going to start from here, then k is equals to 0, which means number of attempts we are going to decide. So, the maximum number of attempts in this case is normally it is for flow diagram it is 15, maximum 15 times you can transmit a single frame. So, that is the maximum limit that has been set by this particular flow diagram. So, for this is the 0th attempt, then send the frame, then we have to wait for the timeout. Now, what is TP? TP is the maximum propagation time, which means like this is the transmitter, this is the receiver, this is TP and this is again TP, which means that an acknowledgement will be received in the feedback path from the receiver to the transmitter. So, it has to wait for 2 times of TP, that is also known as round trip time, maximum propagation time. So, it has to wait for that particular time. If the acknowledgement is received successfully, then the packet is received at the receiver side. If it is not, then the second attempt will be made, because initially k is equals to 0. So, 0 plus 1 is equals to 1, which means now the next attempt will be made, and the maximum limit for this k will be 15. When it crosses the 15th limit, then it will not going to send the data. So, then it has to choose a random number to be between 0 to the power k minus 1, then again wait for TB time, and then this is how the different frames from each station will be transmitted. So, this is the flow diagram of pure ALOHA. Now, next is the vulnerable time for pure ALOHA protocol. So, this is how we have to calculate, like this is the time duration T, this is B's and collides with the A's beginning. Now, you can see that this is the data from the B station, this is the data from A station, this is from the C station. Now, you can see that how this collision or the overlapping of the information is there, like B's and collides with the A's beginning, and in this case A's and collides with the C's beginning. So, this is the duration where the collision will take place and overlapping will be there. So, loss of information will be there. Now, you can see that maximum amount of information is lost in the A frame, because it will collide with B also and it will collide with C also, and this amount of data will be transmitted without any problem, without any collision. So, this is the vulnerable time how you will have to calculate using this pure ALOHA protocol. Now, next is the slotted ALOHA. In case of this slotted ALOHA, as the name itself is self-explanatory, that the time axis is divided into equal number of slots. Now, you can see that like 4 different stations are connected, and this is the time axis. This time axis is divided into equal slots, equal time intervals are there, like this is the frame 1.1, this is frame 1.2, second frame of the first station, then this is frame 2.1, this is 2.2, frame 3.1, this is frame 3.2, this is frame 4.1, then 4.2. So, these are the different frames of each of the station, like station 1, 2, 3 and 4, and these data will be transmitted in their allocated time. Now, in this case also collision will also take place, like here the collision will be there because this ALOHA is the part of random access protocol. It will not going to see that whether the channel is ideal or it is busy, it will going to transmit the data, but in this case there is no there is overlapping of the frames is also possible in case of this slotted ALOHA, but the probability is quite less as compared to the pure ALOHA. Now, this is the vulnerable time for the slotted ALOHA protocol. Now, you can see that the overlapping, the basic difference between this pure ALOHA and slotted ALOHA is that the frame which will going to overlap, it will going to overlap with the full information, like this A and C, both the frames from two different stations will going to overlap and the whole information will be lost. There is nothing some part of this B frame and some part of the A frame will going to overlap. This will be like whole frame will going to overlap. So, A collide with C. So, this whole information will be lost. So, this is the drawback of this slotted ALOHA, that A and C both the frames will be lost, nothing will be delivered at the receiver side. Now, next is the persistent methods. Now, these are the persistent method, like there are three different types of persistent method. First one is 1P, second is non-persistent and third one is P persistent. Now, what does it mean? It is the way that how much a frame should wait, how much time the frame should wait to access a channel. Now, this is the pattern, like in case of one persistent, it will going to continuously sense the channel, that whether it is free or it is busy. Like you can see that this is the channel, up to this duration it is busy. Now, it will going to sense again. Now, since the channel is not busy over here, it will going to transmit the data. So, this is the continuously sensing the particular channel slot. Now, next one is the non-persistent. In this case, it will going to sense the data, then wait for a particular amount of time, that is the fixed amount of time. Again, it will going to sense the channel, then it will again wait for particular amount of time. Then after this, because now this is the drawback of this non-persistent, that up to this duration, because it has to wait for that allocated time that is fixed, till that point it will not going to send the data, because it is also possible that this particular transmitter or the station can send the data at this point also, but it has to wait for that fixed amount of time. So, this duration is you can say that the channel condition, in this case it is free, but there is no option to send the data. So, it has to wait and then sends the and then transmit the data. Now, in case of this P persistent, there is probability outcome does not allow the transmission. So, it will wait for some amount of time, that is time slots are there, that is equally divided time slots are there, and when it will going to sense that this particular channel is free, then it will going to transmit the data. So, this is the basic difference, that this waiting time is not fixed, and in this case the time axis is divided into equal time slots. So, this is how the persistent method will work. Now, this is the flow diagram of the three persistent method, that will make you better understand the different persistent method. Like in this case, one persistent, the channel is, it has to sense, the transmitter will sense that whether the channel is free or busy. If it is busy, then it will again wait for some amount of time, and then it will again sense the data, that whether it is free or busy, then it will transmit the data. In case of this non-persistent, it will wait randomly, there is no fixed amount of time is there. And in case of this P persistent, it has to wait for the probability outcome will be seen, that whether it is greater than P or whether it is less than equals to P, then wait a slot, different time slots are there. Now, this time duration is fixed, then it will again sense the channel whether it is busy or ideal. If it is ideal, then it will going to transmit the data. So, use the back off process as though collision will occur. So, this is the P persistent method flow diagram. Now, next we will move to controlled access method. Now, what is controlled access method? In this case, whenever the data has to be transmitted over the channel from different stations, there is some pattern has to be followed, like every station has some access, that it will going to allow the second station, that whether you can send the data or not. So, there is some control from one station to another station. Like in control access, the stations consult one another to find which station has the right to send. A station cannot send unless it has been authorized by other stations. The three popular control access methods are: first one is the reservation, second is polling, and third one is the token passing. So, these are the three different methods which are used in the control access protocol. So, every station which are connected in this control access protocol, like whether it is following this reservation method, whether it is following polling, or whether it is following this token passing, it can going to ask the other station, the like station A wants to transmit the data, like this is station A, this is station B, and this is station C. Let us say this station wants to transmit the data, it wants to access this channel. Now, it will going to ask this station B and C that whether it can send the data or not. Then this station B and C will allow that yes, you can transmit the data, then this channel will transmit the data following the protocol, whether it is reservation based, polling based, or token passing. So, this is the controlled access protocol concept. Now, first one is under this section is reservation access protocol. Now, you can see that 5 different stations are connected. So, the reservation frame is there. So, in this case, this whichever position is having this 1 bit means it is reserved for data station 1. Now, this section you can see that this is reserved for data station 1, this is reserved for data station 3, and this is reserved for data station 4. So, that means that first station will transmit the data, then third station will transmit the data, then the fourth station will going to transmit the data. So, this is the basic requirement in case of this reservation protocol. Whenever there is 0, which means there the reservation or any station can transmit the data, it is not fixed, but whenever, because this is binary type of communication, whether it is it may be 1 or there are 2 options are there, whether it will be 1 or it will be 0. In case of this 1, it will going to reserve the first station's data. So, data station 1 will be sent, and when this 0 is there, so you can any of the station can access this particular reservation slot, like second station will going to transmit the data or third station will transmit the data. If you want to reserve, you have to put 1 over here. So, that will going to fix the position of a particular station. Now, next one is polling. Now, what is polling? Polling means you have to ask the receiver that I want to transmit the data, you are ready to receive the data or not. So, that is the basic concept behind polling. Now, there are 2 types of messages are there, like first one is the select message, second one is the poll message. In both the case, both different types of cases are discussed in this polling. Now, this is the primary computer, you can say that this will be the sender, and there are 2 receivers like receiver 1 and receiver 2. Same is with this case, this is sender, this is receiver 1, this is receiver 2. So, what how this will going to perform the operation, like primary computer will going to send a message, that is select message. It will going to select this second user that yes, I want to transmit the data. So, then in the feedback path, it will going to transmit an acknowledgement. So, when it is positive acknowledgement, so it is denoted by AKK. So, this is the positive acknowledgement. And when this is NAK, so this is nothing, this is the negative acknowledgement. So, this is positive, this is negative. So, 2 types of acknowledgements are there. AKK means this is the positive acknowledgement, then in return the sender will transmit the data. It will not going to transmit the data directly, first it has to send the select message, that will going to allow, that will going to ask from the any of the station that yes, I want to transmit the data, then in feedback an acknowledgement will be received. then the data will be transmitted, then again the acknowledgement will be transmitted that yes, I have received it successfully. Now, in case of this polling, it will going to ask with every user, every receiver it will going to ask. Like in the first case, this receiver A, it will going to transmit, the sender will going to transmit the poll message that I want to transmit or I want to access any service, that is like let us say here there is a printer connected over here and this sender wants to take a printout from this particular receiver, then it will going to transmit a poll message that I want to take a printout. Now, in return, if the printer is not free, it will going to transmit a negative acknowledgement, or it may be possible that printer is not working well. So, in this case a negative acknowledgement will be transmitted in the feedback path. So, then this sender cannot take printout from this particular system. Now, in the next stage, on the next step, this poll message will be transmitted to this second user. Now, then since it will going to transmit the data, so a data will be transmitted from this particular receiver to this, and then a positive acknowledgement will be transmitted that yes, I have received the message. So, polling basically is a kind of, you are going to ask with every user, like there are 4 users are connected and I want to access the printer and 4 printers are connected to every user. So, I have to ask from every user, like in the first case it will going to transmit the negative acknowledgement, then I cannot access the printer connected with the first computer. Then in the second case it is also possible, with the third case it is also possible, and fourth one. So, it has to ask with the every user, whereas in this case select one, it will directly going to select any computer and then it has to wait for the positive and negative acknowledgement. Now, next one is the token passing. So, this is also a kind of controlled access protocol. Why it is controlled access protocol? Because a token, you can say a ticket or a token which will going to revolve or which will going to transfer from one station to another station. Like there are 4 different topologies which in which different computers are connected. Like first one is the physical ring. Now, you can see over here that 4 different computers are connected in this physical ring. Like this is the first computer, this is second computer, this is third one, this is fourth one. So, 4 computers are connected. So, a token will going to transfer from this one to this one and over here. So, this is how the data will be transferred from this physical ring. So, whichever computer or the node is having the token, it is allowed to transmit the data. Now, second one is the dual ring. What do you mean by dual ring? That the data will be transmitted in both the direction, bidirectional data transmission is there. Like you can see that one way of transmitting the data is this one and one way of transmitting the data is this one, like clockwise and anti-clockwise. So, every user has the right to transmit and receive the data. So, that is the concept of dual ring. So, whichever node or the computer is having the token, it is allowed to transmit, whether it will going to transmit the data or it will going to receive the data, and that is also decided by the frame. Frame is having a section which will have either it will be 1 or 0. So, that will going to decide that whether it is transmitting the data or whether it is receiving the data. Next one is the bus ring. So, this is going to follow the bus topology. So, this is the backbone to which different computers are connected, like 1, 2, 3 and 4 different computers are connected to this backbone, and these are the tap lines. So, these are the tap lines through which this computer is connected to this backbone, and it will going to access the data in this form. So, whichever, again the same concept, whichever computer is having the token, it has a opportunity or it has the it can transmit the data in that condition only. Now, next one is the star ring. So, this is another kind of topology where every computer is connected to, or every node, it can be called as computer, it can be called as node also. So, every node is connected to a single hub. Now, this is the central switch. The main advantage of using the star topology or the star ring is that it will going to, there is security of information is there, like directly the data will be transmitted through this hub, means whichever data wants to transmit, it will be passed through this hub only. So, this is the main advantage of using this star ring. So, these are the 4 different types of topologies or the way in which different computers are connected, so that it will going to access transmit the data using this token passing. So, in today's lecture we have discussed about random access protocol, where there is no definite pattern is there that which computer or which station can transmit the data. It is randomly accessed, it is having ALOHA, and then ALOHA is divided into pure ALOHA, slotted ALOHA, then there is carrier sense multiple access is there. Then next we have discussed about control access protocol, where 3 different types of control access protocols are there, like token passing, then reservation and polling is there. So, these are the, this is all about today's lecture. So, these are the references that you can consider for today's topic.